So, yesterday we had covered some important disasters. We covered floods and droughts. We spoke about tropical cyclones and even cloud bursts. So, let's continue the discussion. Let's cover the remaining disasters today, starting with landslides and avalanches. As we have studied in previous classes, landslide is a disaster that is associated with few other disasters. It is very closely linked with floods and earthquakes. Usually, landslide happens to be a secondary disaster, which is triggered by some other primary hazard. Now, what do you mean by that? It means there is another hazard which is triggering the landslide, like an earthquake happening in a hilly area. The tremors which are induced by the earthquake will weaken the soil structure in hilly slopy areas, causing the slippage of the soil and rock material, which crashes down into the valley. Similarly, floods, heavy rainfall, cloudbursts, they could weaken the soil structure. The soil could become saturated with water. And as the soil structure weakens in the slope, it is going to slip and crash down with all the rock, debris, and even plants and vegetation. This sudden movement of rock, soil, debris, and earth material down a slope is called as a landslide. Is that clear? So, landslide is essentially a type of mass wasting where the mass, that is the rock, soil, and debris, is getting wasted, meaning it is getting pushed down under the influence of gravity. And all this material crashes down into the valley, causing the disaster. Understood? So, landslides are also called as landslips or mud slips. They all mean the same. You might have read in newspapers that recently in Himachal Pradesh there were landslips, or in Uttarakhand there were mud slips. It's not something that's different, it's exactly the same. Landslide is also known as a landslip or a mudslip. In fact, for that matter, even avalanche is exactly the same. Avalanche is also like a landslide. The only difference is that in case of avalanche, it is the ice and snow material which is crashing down the slope instead of soil, rocks, etc. In case of an avalanche, it's the snow which is accumulated in the slope, in the hilly, slopy areas, which crashes down. So we call this a snow avalanche. All right, but the mechanism, the phenomena is exactly the same. So when the slope loses its integrity, when the structural integrity of the slope is compromised, that is when the material crashes down under the influence of gravity. So you can see the images here, which depicts different types of landslides. In the first image, you are seeing a snow avalanche where the snow has crashed down the valley. In the second image, you are looking at debris avalanche where the soil material, including the plants, the trees, everything has crashed down into the valley. Here you can see a rock avalanche. There are certain mountainous areas which is very rocky in structure. You won't find any vegetation. Sometimes even snow cover won't be there. Only the rock material, right? The large boulders, they will come crashing down the valley, causing a rock avalanche. So the names are different depending on what material is crashing down, but the phenomena is exactly the same. This is all a type of mass wasting. It's a movement of material rapidly down the slope. Understood? Now, please note down this point. The third point here in this slide, landslide is triggered by a particular event, as I told you. There is a primary trigger, a primary hazard, which is triggering the landslide to happen. So this could happen because of extreme rainfall, including a cloud burst, or it could be triggered by earthquakes. It could be triggered by flash floods, and this could also be triggered by man-made factors, especially construction activity in hilly, slopy areas. Then movement of heavy vehicles, and as well as explosions that are carried out in hilly mountainous areas. These man-made factors could also be a primary hazard that is triggering the landslide to happen. Now imagine in a hilly area, the government is trying to build a road or trying to build a tunnel or a railway line. So to execute that infrastructure project, a lot of heavy vehicles will be moved into the region. Earth moving equipment like JCBs, bulldozers will be brought in, along with heavy trucks carrying a lot of weight and raw materials. So the movement of such heavy vehicles also induces slight tremors in the hilly slopy regions that could destabilize the structural integrity of the slope. To build these projects, to build even a hydropower dam in a hilly slopy region, explosions will be triggered. Or imagine if there is a mining project going on. So controlled explosions will be carried out to execute these projects, and the shock waves that are induced by the explosion will destabilize the slope and crashes all the material down into the valley. So that is how these landslides or rock avalanches, debris avalanches are triggered. Understood? So if you can understand this basic phenomena, this is more than sufficient. You can easily explain what is a landslide, how is it caused. All right. So I have listed down the reasons. First, the natural factors have been listed out. Let's look at them one by one and then look at the man-made factors. One reason is saturation of the slope because of heavy rains and even due to melting of snow and glaciers. As I told you, when there is a rapid movement of water, when water flows that too at a fast rate due to heavy rains or melting of snow, melting of glaciers, the soil will seep all the water. The water seeps into the soil and the soil becomes saturated with water. So such soil structure becomes weak, and once the integrity is compromised, gravity will pull down this entire material. The risk is higher where the slope has been deforested. In the slope, if deforestation has been carried out, then there is nothing to hold the soil back, because plants, trees, right, they have the ability to hold the soil structure through their roots. The roots play an important role in holding the slope together, and they even arrest the flow of water. They break the speed at which water is flowing, and the roots, they hold the soil together. Now, because of human exploitation activities, if we have cleared all the vegetation, cut off all the trees, then the soil becomes vulnerable in the slopy area. So when there is a sudden flow of water due to heavy rain or melting of snow, all the soil will seep the water. The soil gets saturated, loses the structural integrity, and then crashes down. There is another possibility where water might rise from the groundwater table. Due to capillary action, right, water in the groundwater table might rise up, thereby inducing dampness in the soil. This can happen naturally. All right. In certain places, in hilly, slopy areas, there could be aquifers, underground aquifers, and there could be a groundwater table where the water will start moving upwards through capillary action through the soil, thus inducing dampness into the soil. So from below as well, the soil could become weak, and even this could cause a crash of the soil material. So the removal of vegetation, the degradation of the land itself is a factor. You can see this happening in coastal cliffs as well. There are many coastal areas where right next to the coastline you will have these mountainous cliffs. So even here, the tidal activity, the sea waves which are crashing regularly into the cliff would have weakened the cliff structure, and the soil material might crash into the sea itself. So please understand this complex phenomena. Landslides don't just happen in the Himalayas, right? They happen in many different regions. It can happen in Western Ghats. It can happen in Northeast India, or in other countries where you have cliffside mountains, seaside cliffs. Even there, landslides can be witnessed. The erosion of the slope, the weakening of the slope's structural integrity is the prime reason. And there are many natural factors that can cause this. All right? Even erosion, weathering, even they are factors. These are long-term factors which contribute. The shaking of the surface introduced by earthquakes and even volcanic eruptions. Violent volcanic eruptions, which pushes all the lava, magma, and hot gases out, also induces a lot of shocks and tremors in the slope. Even that could cause a landslide. So don't assume that landslide happens only because of rains and floods and earthquakes. There are other complex mechanisms and phenomena at play, right? They are natural causes that triggers a landslide. Now to this, human activities have contributed. We have basically aggravated the frequency and the impact of landslides. Because of our exploitative activities like construction, deforestation, cultivation in slopy areas, blasting and explosion, mining activity, vibrations introduced by heavy machinery and traffic, large-scale earthwork where soil is removed and moved to a different region for infrastructure projects, spread of urbanization, land degradation because of agriculture and urbanization, all these man-made factors have aggravated the incidence of landslides. Now look at hilly towns of India. Look at Gangtok or Nainital, Mussoorie, the Kulu Manali Valley, right? They're all very popular tourist destinations. So we have exploitative tourism where lakhs of tourists visit these places every year. This is what drives the economy there. So due to lack of regulations, lack of enforcement of the rules and laws, the locals and the business entities which are operating, they would have rapidly expanded their infrastructure. Towns would have expanded, resorts, hotels would have come up in delicate areas, in slopy areas. They wouldn't have followed any construction standards. All these factors contribute to the weakening of the slope. Is that clear? You can see this example live if you go to Uttarakhand, Himachal Pradesh, right? There are plenty of places where you can come across the damage that human activities has caused. Joshimath is a classic example. Joshimath is going through land subsidence, where human activities have directly contributed to the subsiding of the land and the entire slope, and the entire town of Joshimath is at risk. Right? Joshimath is home to lakhs of people. So what they have done is, along dangerous slopes, delicate slopes, lot of houses have been built, hotels have been built. The town and city has expanded without any planning, without any precaution. Existing rules have not been enforced. So we have contributed to these incidents. See, landslides happen naturally, but human activities have contributed to it, and thus we have aggravated the frequency and the impact. It is this interconnection, the complex interconnection, that you should understand. All right? Don't look at this from a very narrow perspective. Don't think that landslides happen only because of floods and earthquakes. They are the primary reasons, but there are other contributing factors, both natural and man-made factors. So once you develop this comprehensive understanding, it becomes very easy to explain this hazard in your own words. You can even draw a small picture in your answers and explain to the evaluator how material can slide down the slope and how it can cause a disaster. Right? When you're explaining this in your own words, you can depict a slope, depict rock and soil material and how it crashes down into the valley. It need not be a very perfect, beautiful image. Even a rough depiction will help the evaluator understand that you know the concept. Then you can list out the reasons, the natural causes, the man-made factors, and then you conclude by saying that we have contributed through man-made activities and we have aggravated the natural factors which is causing more landslides. Then substantiate that with examples. Take examples from Uttarakhand, from Kerala. In Kerala as well, rapid urbanization, large-scale human activity has destabilized the slopes in the Western Ghats. That's why during the monsoon season, right, we witness massive floods and landslides in Kerala as well. So take these real-world examples that you have heard about, quote the examples and explain the phenomena. Got it? So these questions are highly anticipated. In fact, we've already got a question on landslides, but UPSC might repeat the question in a different format. It might ask you to examine the natural causes separately, or it might ask you to examine how human activities have aggravated the natural triggers. It might ask you to give examples of vulnerable places in India where landslides are more common. So such basic questions can be expected, and trust me, it's very, very easy to explain this. Once you get a grip of the complex interaction between man-made factors and natural factors, you can easily bring out the explanation. Now, let me show you the vulnerability of India with regard to landslides. Let's see which parts of India are more vulnerable. You're looking at the hazard map of India with regard to landslides. So according to data that has been brought out by the Geological Survey of India, around 12.6% of India's land area, which excludes the snow-covered region, is prone to landslides in the country. This can be an important statistic for your prelims, because of late, UPSC has been asking a lot of factual questions in prelims. So kindly remember the approximate land area of India which is prone to landslides. If you exclude the avalanche-prone regions in the Himalaya belt, around 0.42 million square kilometers of land area, that's around 12.6% of our land area, is prone to landslides. The highest risk exists over here in Jammu and Kashmir, parts of Ladakh as well, Himachal Pradesh, Uttarakhand, Sikkim, and Northeast India. They face a very, very significant risk. So Himalayan belt is the most vulnerable. Even in the Western Ghats, in the Konkan range, in Maharashtra and Goa, there are many landslides which are frequently witnessed. Just few days back, you would have read about the landslip in Maharashtra at Raigad, right? Many people were trapped, many people were killed. It happened because of heavy rainfall. Even in Karnataka, especially in Madikeri, in the Coorg district, there have been plenty of landslides during the monsoon season. In Kerala as well, in the Western Ghats, Kerala has suffered from landslides and floods. And this is not just a phenomena which is happening due to natural reasons, but man-made factors are also contributing to it. That's why many experts are calling them as man-made disasters. You might have read recent articles in newspapers where experts have called the landslides in Himachal Pradesh as a man-made disaster. What they mean is that, of course, the rainfall, the floods, they're all natural. But we humans have aggravated the risk. We have increased the vulnerability due to our poor planning, due to lack of preparedness, due to lack of enforcement of rules, and due to over-exploitation. All right? Then even in Eastern Ghats, landslides are witnessed at this place the small red dot that you can see in Andhra Pradesh, landslides are reported in the Eastern Ghat ranges. Does anyone know which place is this? Can someone tell me in the comments? Which is this place in Andhra Pradesh that I have marked? The small region in Andhra Pradesh, which is prone to landslides in the Eastern Ghats. Janvi has got the right answer. Very good. And few others are also giving another location. Okay. Shanvas, Srinivas also have got the right answer. This location that has been marked here, it is the Araku Valley near Vishakhapatnam. Araku Valley is known for its plantation crops. Since the British era, plantation crops have been grown here in Araku Valley of Andhra Pradesh. Even in the Tirupati region, in the Sheshachalam ranges as well, near the popular iconic temple town of Tirupati, even there floods and landslides have been witnessed. All right. So these are the regions in India which are the most vulnerable. So having this basic awareness will help you answer questions in your prelims and also in mains. In mains, any question on landslides, you have to point out some regions in India which are the most vulnerable. Give some data. In one paragraph, you can explain this. Point out which regions are most prone. All right. So in the northeast Himalaya region, stretching from Darjeeling to Sikkim, all the way till Myanmar's border. In the northwest Himalayas as well, across Uttarakhand, Himachal, J&K and Ladakh. Western Ghat ranges across all these Western Ghat states. Even in the Nilgiris, the Nilgiri Biosphere Reserve, which is shared between Tamil Nadu, Kerala and Karnataka. Right? Even here landslides are witnessed. And Eastern Ghats as well, in the Araku region and in Tirupati as well. Is that clear? So understanding the vulnerability of India is very, very important. Now, can you guys tell me, where can we witness snow avalanches? Can you give me any locations in India, any specific location in India where snow avalanches are very common? Not the state. Don't mention the state. Any specific location. Siachen, very good. Gulmarg. Siachen, Gulmarg, near Gangtok, near the India-China border between Gangtok and Nathula Pass. Even Kulu, very good. Kulu Manali sector as well has seen snow avalanches. All right. So there are few places in Himachal Pradesh, Uttarakhand, J&K and Sikkim where snow avalanches are quite common. You have to remember Siachen because that is where Indian troops are also deployed with regard to our dispute with Pakistan. Right? Siachen is a standing dispute, but India largely controls the Siachen Glacier. It's the world's highest battlefield. India loses a number of soldiers. Even Pakistan loses a number of soldiers at Siachen due to snow avalanches. Even though we haven't fought a battle or we haven't fired a single bullet at Siachen, we have lost close to 900 soldiers. And Pakistan has lost even more. It has lost more than 1,000 soldiers in the last 30 years at Siachen. And it's all because of snow avalanches and other adverse conditions like hypothermia, frostbite, etc. But snow avalanches happens to be a major threat for our troops that are stationed at Siachen. All right. So if you have this knowledge about India's vulnerability, this is more than enough. Now coming to disaster management with regard to landslides. How do we deal with it? From a disaster management perspective, how can we plan? How can we prepare? How can we implement the disaster management cycle so that we can prevent the disaster or at least mitigate the disaster? Because please remember, in the case of landslides, it is possible to prevent the landslide from happening. Through right planning, through preparedness and the right measures, we can prevent some of the landslides. If not preventing, we can at least reduce the impact, mitigate the impact. So obviously, the first step is to create a hazard vulnerability map which is part of the risk analysis. Correct? Without understanding the risk, how can you plan? How can you prepare? Right? So in pre-disaster phase, one of the first steps is risk analysis, where you conduct scientific studies, you conduct geological studies, link that data with meteorological phenomena, look at historical data where landslides have happened, right? Use all the data and develop detailed hazard vulnerability map for the country. It's not just enough to point out which states are vulnerable or which districts are vulnerable. We have to develop micro level data. In case of landslides, micro level data is needed at the level of every slope, every mountain, every hilly area. We should develop enough geological data based on which we can estimate when a landslide might happen. What is the risk of a landslide happening? So broad nationwide data is not just enough. Like the map that we saw, that is only for common man's understanding. But experts in disaster management, if they have to take preventive measures, they need micro level data. All right? It's not just about pointing out which state is vulnerable, which district is vulnerable. It's about pointing out which slope is vulnerable, which mountain is facing the biggest risk. So such micro level data has to be brought out as part of the early warning system. This is possible. Today we have enough technology in place. We just have to scale it up. India is already experimenting with this. We have started implementing an early warning system for landslides. Let's talk about that. Let's talk about the National Landslide Susceptibility Database, which is being created. It's an ongoing exercise led by Geological Survey of India and few other institutions. So by using satellite data, by using ground-based sensors, the structural integrity of the slope can be measured at the micro level. So India has launched this ambitious program called the National Landslide Susceptibility Mapping Program. We are essentially creating a database for the country to pinpoint which slopes and mountains are the most vulnerable. Using GIS data at a very micro scale, we are developing a detailed map so we can pinpoint to the authorities that these are the slopes which are facing the highest risk. Got it? So please make a note of this. We are putting in place an early warning system. It's not fully ready, but at least the model, the technology is there. We have to scale it up. It might take few years, it might take maybe a decade. But if we are able to implement this across the vulnerable regions, then the disaster management authorities can figure out which areas are the most vulnerable, and accordingly they can take precautions. Is that clear? So please make a note of National Landslide Susceptibility Mapping Program. Got it? It is developing micro level data to pinpoint the vulnerability of different slopes and mountains so we can prepare for the upcoming disasters. So based on this information, you create a zonation map and enforce your zoning standards. Once you know which slopes are most sensitive and vulnerable, you can prohibit construction activities. You can prohibit deforestation. You can even prohibit urbanization of these vulnerable slopes. And where prohibition is not possible, you can at least restrict and regulate the human activities in these vulnerable slopy areas. This is where zoning standards will help. The local authorities, district level authorities, state governments, they have a bigger role in enforcing these zoning standards. So plan the land use. How you're going to use the land, plan it accordingly and regulate all the construction activities, economic activities, and human activities. If we can do this strictly at the ground level, we can mitigate the impact and even possibly prevent the disaster. Promote afforestation in the slopy areas, right? Tree cover will act as a natural buffer. We can even take up many structural measures like building retention walls. If you, let's say, already have a village present in a slopy area, you can protect those villages instead of rehabilitating the people by building retention walls, which can hold back the soil material even if there is a landslide. Right? So, such structural measures can also be taken up. You can use strong structural materials like concrete, steel, and build these barriers and structures that can hold back all the debris that might come crashing down in order to protect the villages and the habitations present in these areas. You can even consider other non-structural measures such as eviction of few villages and towns. In a worst case scenario, like Joshimath, for example, where any other solution is not possible, right? The only option left is to evacuate that region entirely. So incentivize the people, give them land elsewhere, give them support, financial support to build a home, and ask the people to move out and evacuate that whole region so that people are not present when a disaster happens. That is a last option, a last resort in worst case scenarios. So all these measures can be thought of in the disaster management cycle. Is that clear? Then, of course, during disaster, you have to build your relief and rescue capabilities. Because when there is a landslide, there will be a lot of material which has crashed. So you need a lot of equipment to remove the material in order to save the people who are trapped. So we have to prepare for this. In the landslide prone areas, the disaster response forces have to be stationed with the right equipment and the right training and skills. So they can rush to the area and clear the material as soon as possible to save as many people as possible. After the disaster, focus on recovery, focus on reconstruction. So broadly, these are the measures we can take under the 3 stages of the disaster management cycle. Got it? So it is possible to prevent the hazard from turning into a disaster, or at least we can mitigate the impact of the hazard and minimize the impact of the disaster. Clear? Now, I would like to give you an example here, a recent example which occurred. I would like to talk about the Chamoli disaster that happened in 2021 in Uttarakhand. This is a case study based on a recent disaster which happened in Uttarakhand. I'm sure some of you would remember this incident, the Chamoli disaster. A lot of people were killed because of a flash flood. There was a massive flash flood in the Rishi Ganga and the Dhauli Ganga rivers that you can see in this satellite picture. All right. There was a massive flash flood in the downstream areas that destroyed many villages in the downstream. It even destroyed a hydropower plant. The Tapovan hydropower station was completely damaged. Many workers were trapped in the hydropower plant and many workers were killed as well. So initially, when the disaster occurred, experts were still not sure as to what caused the flash flood because the region hadn't received heavy rainfall. Before the disaster, few hours before the disaster, there was no heavy rainfall that had occurred. So rainfall and cloudburst was ruled out. So experts pointed out it might have happened because of a glacial lake outburst flood, which we are going to study next. They predicted that maybe there was a glacial lake in the higher reaches which has burst open, which has released a lot of water into the downstream that might have caused the flash flood. This was the initial assumption. But later studies confirmed that it did not happen because of glacial lake outburst flood. The reason was pointed out. It occurred because of a rock avalanche. Essentially, it was a massive landslide that had happened. Now, please concentrate on this image. There were many satellites which were monitoring this region, including a European satellite called the Sentinel satellites. So Indian researchers and as well as European researchers, they figured out what caused the flash flood. Can you see this box over here? This area which has been zoomed in. You can see here this entire triangular region. This entire triangular area of that slope is missing. Everywhere there is snow and rocky material. But in this triangle, the material looks very fresh, very clean, because this entire piece of material had slipped and crashed into the river below. So it's like a mini tsunami which had been generated. Now, what happens if you, let's say, you take a bucket which is filled with water, all right, to the brim, the bucket is filled with water. You take a big piece of stone and drop it into the bucket, right? Obviously, the water will spill over. That too, in a violent action, the water will splash out from the bucket. That is exactly what happened at Chamoli. This rock slippage, this landslide or a rock avalanche that happened, a massive piece of rock slipped and crashed into the river below, triggering a mini tsunami, which is nothing but a flash flood. Got it? So this was the Chamoli disaster. Initially, it was assumed that it was because of a glacial lake burst, but later studies and satellite data confirmed that it was because of a landslide which had happened. It was a rock avalanche, a massive piece of rock. This is a very, very big piece of rock. In the image, you can't realize the scale of it, but in reality, it's a very, very big piece of rock that had broken off and it crashed into the river below, triggering the flash floods in the downstream. So these are the kind of disasters which you can't prepare for. It's very difficult to anticipate them. But with right studies, with understanding of the slope, studying the structural integrity of the slopes, it is possible to estimate the vulnerability. Based on that, we can take some measures in the downstream areas, in the vulnerable areas. All right. So retention barriers can be built to contain the flash floods, or the flood water can be diverted. You can prevent construction activities, urbanization, and the spread of villages and towns. So by taking those long-term measures, we can prevent or at least mitigate the impact. So Chamoli disaster was a wake-up call. It was a natural disaster, without doubt. It happened naturally. But human activities aggravated the impact. It would have just been a hazard if we didn't have a dense population in the downstream, right? So those are the measures that are needed to reduce the impact of these disasters. The same was the case with Kerala's floods and landslides. This is another example, another case study for you. In 2017, 2018, almost every year during monsoon season, Kerala receives massive rainfall in the Western Ghats, particularly on the windward side of the Western Ghats. Right? This brings a lot of water into the west flowing rivers of Kerala, and it triggers floods. Why the damage in Kerala is very severe almost during every monsoon season. Same is the case with Madikeri in Karnataka. Many of you would have heard about Madikeri, very popular tourist destination, known as the Scotland of India, right? Even in Madikeri, there is overexploitation. Tourism is overexploited. Plantation, commercial crops are overexploited. So because of this, the slopes, the whole ecosystem has been compromised. There is large-scale deforestation, weakening of the slope and its integrity. And when there is heavy rainfall, it causes massive landslides in Madikeri in Karnataka. Same with Maharashtra and Goa. In the Konkan belt of Western Ghats, there are many dangerous slopes where we humans have aggravated the risk, and during monsoons, floods and landslides become quite common in the entire stretch of the Western Ghats. All right. So please pay attention to these kind of disasters which are happening regularly. In the last 10 years itself, we have seen many devastating floods and landslides. You take any example as a case study, all right? That will help you substantiate your argument and justify the answer. You can take the example of Kedarnath floods in 2013, right? Kedarnath floods caused massive devastation in Uttarakhand. There was a massive avalanche in Sikkim few years ago. So make a note of all these examples, use them to further justify your answer. All right. I hope you guys have understood what is a landslide, what's the mechanics involved in a landslide, what causes it, what's the complex connection between natural and man-made factors, the vulnerability of India, and how can we manage this disaster. So if you're aware of all these key points, you can easily write an answer for any question on this topic. Is that clear? Now, please be prepared for a possible essay topic as well. In your essay paper, UPSC might ask you a very broad question on disasters. Maybe a question on how man-made activities are increasing the natural risk factors, the natural hazards, causing more deadly disasters. Because India and the world, right, we are suffering because of these incidents which are happening repeatedly. So you can anticipate an essay and you have to interlink all these topics we have discussed and you have to structure your essay accordingly. So floods and landslides will be the perfect example for you to show how man-made activities have increased the risk factors for natural hazards, which is turning into more frequent disasters and deadly disasters. Right? So more examples you're aware of, it's better for you. That's why I told you, please make a list of these major disasters which I'm mentioning, or any future disasters which will happen, which will be reported in newspapers. Just make a list, make a note when it happened, where it happened, and directly use them in your answers. All right. Now, if you guys have any doubts, any questions, please let me know. Because after this, I'll be moving to the next topic. Just let me know if you have any questions. Santosh is asking, sir, what's the reason for Kedarnath floods? It's exactly the same. In Kedarnath, there was massive rainfall. Heavy rainfall was received for several days that triggered flash floods. The flooding in turn caused landslides. Right? It's the same reason everywhere. Mithun is asking, what's the basic difference between landslide and avalanche? In a landslide, it is soil, rock material, and other debris which is sliding down. In avalanche, it is usually snow which is crashing down. Generally, the word avalanche is used for snow crashing down a snowy, slopey area. Landslide refers to other mountainous areas where snow is not present, but soil, rock, and other debris and vegetation will crash down. That's the only difference. Sir, can you show previous mains questions? Of course I will, but at the end. Let's complete all the topics. At the end, I'll show you all the questions. We'll discuss some of the questions as well. Don't worry. Because you need the knowledge first. You need to understand the concepts, the theories, the examples. Then we'll look at all the previous questions. Santosh is asking, in essay paper, is there any word limit? Of course, 1500 words is the limit in your essay paper. Pushpendra is asking, can landslide become a primary disaster in any case? Usually, it can't happen, right? Because the weakening of the slope is triggered by some other factor, either by an earthquake or due to deforestation, due to explosions, or maybe floods and rains. There's always some factor which is triggering a landslide, right? So landslide does not happen usually on its own. Yes, the structural integrity might weaken naturally as well, but it's very rare. But there is always some trigger which is contributing to a landslide. Shweta is asking, debris avalanche not understood. It's very simple. What is debris? Debris is basically waste material, right? Debris refers to soil, the vegetation material, the rocks, the boulders which are present. When all of that comes crashing down like waste material and falls into the valley, that is a debris avalanche. Nikat is asking, in Chamoli, was it not a primary disaster? Yes, Chamoli is a rare example, right? The rock's structural integrity weakened naturally over a period of time and it crashed into the river below. So, Chamoli incident is a case where the landslide happened on its own without any external trigger. But as I told you, it's very rare. It's a very rare occurrence. Chamoli is where? Chamoli is in Uttarakhand. Devansh is asking, recent flash flood is an example of meteorological hazard? Not exactly. Flood is a hydrological hazard, as I explained in the first class. Cloudburst rainfall, extreme rainfall, is a meteorological hazard. Those meteorological hazards trigger a hydrological hazard, which is a flood. So please understand the connection. All right. Reasons for Kerala flood and landslides. I just told you, heavy rainfall, cloudbursts. That is what causes floods and landslides, along with the man-made factors. Anything else? Guys, please let me know if you have any other questions. Sir, in prelims, how many questions can come from disaster management? I addressed this in the first class itself. In prelims, you can't put an exact number, but you might get some questions. You might get 3 or 4, maybe 5, maybe 0 as well. You never know, right? Prelims is very dynamic, but always be prepared. You will get few questions in prelims which are linked with disaster management. There are many questions on GLOF. Don't worry, that is the next discussion. Next topic is GLOF. So we'll study GLOF in detail. So please wait. Karthik is asking, sir, any website to know about recent disasters? Any newspaper, right? Or any media website, Hindu, Indian Express, NDMA website, even our current affairs sessions, that will always cover all the major disasters. Devansh says, sir, is there a possibility? No, but flash flood cause was western disturbance and southwest monsoon winds. That is the meteorological phenomena, right? Western disturbances and the monsoon is the meteorological phenomena that caused heavy rainfall, that caused the cloud burst, which then triggered the floods. So it's a meteorological hazard causing heavy rainfall, causing cloud bursts. That leads to a hydrological hazard, which is a flood. Santosh is asking, sir, in answers, can we include these case studies? If we include, how many lines should we limit the case study? See, when you're explaining a disaster, first you explain the mechanics, the factors, the impact, and then in the body, one paragraph, maybe in 3 to 4 lines, give the examples. Giving examples from current affairs is always a plus point. That shows to the evaluator that you not just know the concepts and the static part, you are in touch with the dynamic part as well. So maybe in 3, 4 lines, when you're about to end the answer, when you're about to go to the conclusion, there give the examples. In 2, 3 lines, explain that such incidents happened recently, and this shows how dangerous these disasters are. 3, 4 lines, you can explain some recent disasters as a case study. Anurag has a very good question. He's asking, what's the difference between landslides in Himalayas and Western Ghats? There is a difference. Landslides in Himalayas might happen because of earthquakes as well, along with floods and landslides, right? In Himalayan ranges, there are many reasons contributing to the landslide. It could be a flood, it could be heavy rains, cloudburst, glacial lake outburst flood, or even earthquakes. But in Western Ghats, the reasons are slightly different. Western Ghats don't witness earthquakes and there are no glaciers. So that is a key difference. This could actually come as a prelim statement. Correct? A statement might say that earthquakes cause landslides in Western Ghats. It's a wrong statement because the Deccan Plateau, Western Ghats are very stable in their structure. The region is not prone to earthquakes, so earthquakes are not known to induce landslides in Western Ghats, whereas it happens in Himalayas. The landslides in Western Ghats is mainly because of heavy rainfall. That's the primary reason, along with the man-made factors. But in Himalayas, all the reasons are responsible. Heavy rainfall, floods, cloudbursts, glacial lake outburst flood, and earthquakes. So kindly note down this difference. All right? This could come as a prelim statement. Okay. So guys, these were some of the questions. Now let's move on to the next topic, the next hazard, which is GLOF, Glacial Lake Outburst Flood. According to me, it's a very important topic because India has witnessed few GLOF disasters recently. And also the risk of these hazards will increase with global warming and climate change. Global warming and climate change plays a direct role in increasing the risk of GLOF events. All right. So what is GLOF? It stands for Glacial Lake Outburst Flood. Again, the understanding is actually very simple. The name itself tells you what is the disaster all about. You have a glacier and a lake at the bottom of the glacier, which is getting breached, which is bursting open, releasing all the water, causing a flood. As simple as that. But let's look at the dynamics as well with the help of this infographic. There is a small picture that I have added so you can understand how GLOF disasters actually happen. In simple words, you have a glacial lake, a lake formed at the bottom of a glacier, which is going to breach and burst out open, releasing all the water all of a sudden. It's like a dam which is holding all the water back. And what happens when the dam breaches, right? The entire water will rush down the stream and it's going to flood the downstream areas. So let's understand the mechanics involved. Let's understand this from a geography point of view. So for this disaster to happen, first you need a glacier. All right. So in India, the only place where GLOF can occur is the Himalayas, where we have thousands of glaciers. From the Indus Basin to the Ganga Basin to Brahmaputra Basin, there are thousands and thousands of Himalayan glaciers present in India, Nepal, and some in Tibet as well. Obviously, glaciers are nothing but large sheets of ice. These are massive sheets of ice. In fact, the Himalayas holds so much water in these glaciers that the Himalayas are referred to as the third pole of the world, the third polar area of the world. See, the Earth has two poles, North Pole and South Pole, the Arctic and the Antarctic. That's where you have these massive ice caps and glaciers, correct? These glaciers are basically frozen water, basically ice. These are massive sheets of ice which is holding massive volumes of water. So just like Arctic and Antarctic are holding glaciers and frozen water in these ice sheets, similarly in the Himalayas, we have many glaciers holding a lot of water. That's why it is often referred to as the third pole. All right, it's called the third pole because of the large presence of glaciers in the Himalayan mountains. Now, what happens to the glaciers, the ice? Obviously, it will melt. It will melt naturally during the summer season. When temperatures increase slightly during the summers, glaciers will obviously melt. And man-made factors like global warming. As global average temperatures increase, the glaciers are melting at a faster rate. You would have read about the faster melting of polar ice caps in the Arctic and the Antarctic, which is contributing to rising sea levels. Similarly, the rising global temperatures because of climate change is accelerating the melting of these glaciers in the Himalayas as well. And all the water which melts, all the water which is coming out of these glaciers will accumulate at the bottom of the glacier, forming a lake, which is called a glacial lake. Now imagine a massive column of ice. If you look at the image here, you can see the glacier is depicted over here. This entire block of ice, this entire sheet of ice is the glacier, which is holding massive volumes of water within it. So because of summer season, because of global warming, the glacier will naturally melt, and we are accelerating the melting process because of the climate change we have caused. And all the water accumulates at the bottom of the glacier, which is nothing but the glacial lake. Now, this is like a reservoir, it's like a dam. So, there is a natural structure which will be holding the water back. So, many reasons are present which can trigger the burst of this glacial lake. Many natural and man-made factors can lead to the complete burst of the lake, which pushes the water down, causing a disaster in the downstream area. For example, imagine if there is a glacier in the mountainous region, there could be snow as well. What if there is a snow avalanche? What if the snow comes crashing down into the glacial lake and pushes the water out in one sudden movement? So a snow avalanche in the nearby mountains where the snow is crashing into the glacial lake can burst the lake and push the water down, causing flash floods. That's one possibility. Or there could be a regular landslide. There could be a regular landslide. Now imagine in this mountainous area, the rock material, all the debris, the stones, boulders, they might come crashing down into the lake and thus pushing the water out and bursting the glacial lake. So a landslide or a snow avalanche could be a potential reason that causes a glacial lake outburst flood. I'll give you one more example. What if there is heavy rainfall or a cloud burst in this region? Now, this will suddenly bring very large volumes of water, which fills up the glacial lake, and the glacial lake could get burst. It may not be able to hold the water back, and this also triggers a flash flood. So, there are many such regions that one can imagine, right? In these areas, there are many hazards, many risk factors which can cause the breach of the glacial lake. Like Chamoli disaster. What if an entire piece of rock slips and causes a rock avalanche? And the rock that falls into the glacial lake can breach the lake and push the water out, causing a flash flood. Is that clear? So all these factors could be responsible. So this is a natural hazard, but we humans again have accelerated it. Because of global warming, glaciers are melting at a faster rate, thus increasing the risk of GLOF events. Understood? I can repeat this if you want. I can just summarize it. In mountainous snow-capped areas like the Himalayas, we have glaciers present at the higher altitudes. Glacier is nothing but large sheets of ice, large blocks of ice that is holding massive quantities of water. These glaciers are naturally melting during the summer season. Natural melting process is not a threat, but we have accelerated the melting of glaciers through global warming. So the water which accumulates here at the bottom of the lake, at the bottom of the glacier, is called a glacial lake. This natural dam-like structure can be breached because of many reasons. It could be a snow avalanche, a landslide, a rock avalanche, or heavy rains, cloudbursts, or an earthquake triggering a landslide and then causing a GLOF event. So it could be a combination of these. So such a burst of a glacial lake is called GLOF event. Essentially, it turns into a flash flood. Is that clear? The flash flood in turn can trigger more landslides. Landslides in turn can trigger flash floods. So this is a very, very complex equation that you're talking about. Is that clear? In the real world, these interconnections are very complex, where one hazard is driving the other. That is the reason why in sensitive areas like Himalayas, where the ecology itself is very delicate, we should not disturb the ecological balance. If you increase deforestation, if you take up construction activities in these sensitive locations, and if you are emitting more fossil emissions, greenhouse gas emissions, contributing to global warming, of course, such disasters are going to happen more frequently. Is that clear? So GLOF is one event which causes a flash flood that in turn could cause landslides as well. This could be triggered because of other primary hazards like a landslide or a heavy rainfall, cloudburst, or snow avalanche. Any of these reasons could be responsible for the breach of the glacial lake that pushes all the water, thus threatening the downstream villages and towns. So India has experienced such GLOF events. All right, we have experienced these kind of disasters, and even in other parts of the world, in the Alps region, right, even in the Andes mountain region, wherever you have glaciers, GLOF hazard is a very real threat. All right, now let's look at the vulnerability of India, the vulnerability of the Himalayan ranges for GLOF events. Where do you find these glaciers and glacial lakes? That is a basic knowledge you should have. Now, please look at the map. The map is depicting the distribution of Himalayan glaciers. According to the studies which have been conducted, most of the glaciers in the Himalayan ranges are concentrated in the Brahmaputra basin. Please note down this point. Very, very important for your prelims. There are more than 25,000 glacial lakes across the Himalayas, stretching from Afghanistan, Pakistan belt over here near the Hindu Kush range and the Amu Darya river near Afghanistan, Pakistan, and Central Asia. From here till Myanmar, till the Irrawaddy basin. This is China, this is Myanmar, right? This is where the Himalayas end, near Arunachal Pradesh. So here you have the Irrawaddy river basin, we have the Amu Darya river basin, Indus river basin, Ganga river basin, and Brahmaputra river basin. So across these major river basins of the Himalayas, we have a total of 25,000 plus glacial lakes. There are plenty of glacial lakes towards the Pakistan side of Himalayas, that is towards the Hindu Kush Amu Darya ranges. Little below, towards India and Pakistan in the Indus basin, we have plenty of glaciers, right? In Tibet, in Ladakh, in Jammu and Kashmir, in Pakistan as well, in Pakistan occupied Kashmir, we have plenty of glaciers in the Indus belt. In the Ganga basin, in Uttarakhand, in Nepal, right? In this region as well, we have plenty of glaciers. In Sikkim also. then in the Brahmaputra basin, particularly in Tibet and in the higher reaches of Arunachal. So in total, we have around 25,600 plus glacial lakes, and majority of them are in the Brahmaputra basin. Please note down the point. It has the highest number of glacial lakes. This is followed by the Indus, then comes the Ganga basin, Amu Darya and Irrawaddy. This is the distribution of glacial lakes in the Himalayan belt. So as far as India is concerned, Brahmaputra basin, Indus basin and Ganga basin, these are the concerns for India. So obviously, the biggest risk, the highest vulnerability is in states like Himachal Pradesh, Uttarakhand, Sikkim, and even Ladakh, Arunachal Pradesh, and Jammu and Kashmir. They are also at the risk of experiencing such flash floods and landslides, which are triggered by glacial lake outburst. Is that clear? So this is the vulnerability depending on the distribution of the glacial lakes. Now let's see what NDMA is advising us regarding GLOF events. The National Disaster Management Authority has come out with a set of guidelines as far as this hazard is concerned. According to the NDMA, the first step in disaster management, should be to identify and map out these glacial lakes. It is nothing but risk analysis. See, guys, I told you yesterday itself that once you understand the first 2-3 disasters, the process, the approach is the same for every disaster. You don't have to really scratch your head. You don't have to mug up things. Once you understood the disaster management cycle, the 3 stages and the steps involved in it, you can apply the same approach for every single disaster. So even for GLOF, you study the risk. You apply scientific knowledge. You conduct scientific studies and assessments and create a hazard map. Identify the glacial lakes, their distribution, study the risk present. Today we have satellites, we have drones, we have advanced sensors available that you can deploy to get real-time data to monitor the health and the integrity of the glacial lakes. Is that clear? We can install sensors around the glacial lakes which are more vulnerable to look out for heavy rainfall, to look out for a landslide or a snow avalanche which can cause the glacial lake to burst out. So if we track such events in real time, we can give alerts in the downstream areas which might give them few minutes or few hours notice within which the people can be evacuated to a safe place. Correct? Once the glacial lake bursts open, you still have few minutes, maybe 1 hour or 2 hours left before the water floods the downstream areas. This is precious time. Only thing we need is real-time tracking of some of the glacial lakes. Of course, we can't track all the thousands of glaciers. It's impossible. But through scientific studies, through risk analysis, we can identify the most vulnerable glacial lakes. By using the right technology, by using satellites with synthetic aperture radar. Synthetic aperture radar, this payload on an Earth observation satellite can give you high resolution pictures even during the night and even when there is cloud cover. Your regular Earth observation satellites, which have optical cameras, they can't capture good images during night and when there is heavy cloud cover. But synthetic aperture radar overcomes the limitation. Synthetic aperture radar satellites, like the RISAT satellite that ISRO has launched, right? And we are also launching a satellite for Singapore in a few days, which also has a synthetic aperture radar. Such Earth observation satellites, which have SAR payload or synthetic aperture radar, They can take pictures even during the dark and even when there is cloud cover. They can give you real-time surveillance, constant real-time surveillance of these sensitive glaciers. Or you can deploy drones and install a network of sensors at the ground to track the threat. You can look out for the rate of melting of the glacier, the rate at which water is getting added into the glacial lake. Look out for other hazards like earthquakes, landslides, heavy rainfall, and floods that might happen near the glacier. And based on that, issue real time alerts. Once we put in place such a surveillance system and an early warning forecasting system, we can give some window of time for timely evacuation of the people. The local authorities, if they are trained and if they know what to do, once the alert goes out, immediate evacuation can be taken up within minutes, within 1 hour. So before the flash flood occurs, you can save plenty of people. This is an essential step. If not at all the glacial lakes, at least the most vulnerable ones. Maybe we can identify the 100 most vulnerable glacial lakes and put in place a real-time tracking surveillance mechanism using all the technology available. And if you can track these threats, you can detect the burst of a glacial lake and give out the alerts in real time. India is working on this. It will take time. It might take 5 years or 10 years. But we will have such a surveillance and tracking mechanism in the future where we can keep track of the sensitive, vulnerable glacial lakes and identify the burst which happens in real time. And once the alerts are given, you can evacuate the people, thereby reducing the impact. Next, every other measure is the same as floods and landslides. Because eventually, what does GLOF do? GLOF causes floods and landslides. So whatever we discuss there, the same will apply here. All right? Your zonation standards, flood control mechanisms, building dams, diverting the flood water, creating embankments, building retention walls, enforcing your building standards and zoning standards. All these measures can be suggested again. You can even add training of the local community, awareness, etc. The same points, whatever we have covered under floods and landslides, the same points can be added here as well. Got it? So you have to understand what is GLOF, how is it caused, in India, which areas are most vulnerable, what is the distribution of the glacial lakes in the Himalayan belt, and what does NDMA say about this hazard? How can we put in place a early warning system? How can we carry out the risk analysis and install a early warning system? If you can understand this much, it is more than sufficient. Every other measure is the same as that of floods and landslides. Understood? So this completes my small discussion on GLOF events. Now, if you have any questions, let me know. As I told you, it's a small topic. Do let me know if you have any doubts. Only then I'll start the next topic. Audio is not proper. 3-4 students are saying audio is not coming. Guys, just let me know in the comments if there is any technical issue with the audio video. I think for majority of you, it is fine. Only few students. Okay, I think it's your internet connection. Please check your internet connection. It's absolutely fine. Hundreds of students are saying it's fine. If the audio video is stuck, please refresh the page or check your internet connection again. What is the difference between lake and river? Don't expect me to answer this question. I'll not give you the answer as well. If you go and ask a first standard student, he will tell you what is a lake, what is a river. This is not expected from UPSC aspirants, right? And I believe you have covered your geography classes as well. Please go back and read what is a lake and a river. You can't ask such questions. That is shocking. Mithun is asking, sir, is it preventable? GLOF, is it preventable and can we mitigate? See, prevention might be difficult given the places where glaciers are present. It's in very high altitude and the terrain is very complicated there. So, for any intervention for us in such an area, it's very complicated. And also, if we take any measure, right, more construction, it will increase the risk. So, prevention may not be possible, but mitigation is definitely possible through disaster management planning and preparedness for floods and landslides, and through an early warning system for GLOF events, we can mitigate, reduce the impact. That is definitely possible. Santosh is asking, sir, GLOF occurs only in summers or throughout the year? GLOF events can occur anytime during the year, not only during summers, even during rainy season. In fact, the risk is more during rainy season because heavy rainfall, cloudburst can trigger GLOF outburst, right? So it can happen anytime, not just during summers. Abhishek is asking, recently, which states have been impacted by GLOF? Uttarakhand and Sikkim, they have been affected by GLOF. Santosh is asking, sir, how sensors can play a role in GLOF events? See, by installing sensors near these glacial lakes, you can detect the breach of the lake. You can detect the flow of water. You can estimate the rainfall being received. You can even detect landslides or earthquakes occurring. Based on that sensor data, you can figure out that glacial lake has burst and then you can give out alerts. Montu is asking, what's the difference between GLOF and floods? GLOF is a primary hazard causing floods in turn. The burst of the glacial lake is causing floods. That is the primary difference. They are both related. GLOF causes the flood. That's why I gave you the example. Imagine a dam which is holding a lot of water in the reservoir. Now, what will happen if you burst the dam? Imagine hypothetically you burst open the dam, suddenly the water will gush. The entire water in the reservoir will flow in the downstream, causing floods. That's what happens in case of GLOF. The burst of the glacial lake releases all the water, causing flash floods in the downstream. Anurag is asking, sir, why people are concentrated in hilly areas like Joshimath? Isn't second tier and third tier cities capable to accommodate them? See, Joshimath has always been a popular commercial town and also for religious reasons as well. So people have settled at Joshimath from a long time, right? So today, given the risk of land subsidence and other associated risks, government should consider relocating the people, right? That is the only option in a worst case scenario. So if you ask me why people have settled, it's because from a very long time, from centuries, Joshimath has been a popular town, a residential place. There's a religious significance attached to it as well, right? So that's why the population density is higher at places like Joshimath. Shivam is asking, sir, since downstream people are the most affected when such disasters happen, what measures the government can take regarding this? As we discussed, since downstream people are the most affected during floods and landslides, the measures need to be taken includes clearing these areas, ensuring that we don't encroach on riverbeds, ensuring that building codes, zoning standards are implemented, ensuring that we divert the flood water, build retention walls if necessary. Those are the same measures we can take to protect the downstream population. Santosh is asking, sir, is there any other man-made factor that aggravates GLOF other than global warming? Usually, there is no other man-made factor because glacial lakes are present at very high altitudes. Usually, we don't have any human habitation there, no construction activity as well. So, direct involvement of man-made factors is almost minimal, up except for global warming. Global warming is the main trigger, which is a man-made factor aggravating GLOF. Other than that, it's very rare for human activities to directly contribute to it. Maybe imagine a scenario where there is a conflict. I'm telling this because India, China, right? They share the Himalayan border. Imagine there is a conflict going on and there is an explosion near a glacial lake. Then it is possible, right? But in general, in reality, it doesn't happen. So apart from global warming, you don't have other man-made factors that is directly responsible for GLOF. Anu is asking a question. If GLOF is caused due to landslides or avalanches, can we call it a tertiary disaster as landslides, avalanches are secondary disasters? Yes, you can, but depends on the sequence of events, right? It depends on the actual incident. Now, in one place, there might be an earthquake. Earthquake is primary disaster. Earthquake causes a landslide. Landslide is secondary disaster. That triggers GLOF event, becomes a tertiary disaster, right? It may not happen in the same sequence everywhere. In other places, when the incident happens, the order might be different. Maybe the glacial lake lost its integrity due to weathering, due to erosion, all right, or due to sudden melting of the glacier. Maybe the lake lost its strength and integrity and burst open on its own and then caused landslides and floods. So, depending on every disaster, you have to figure out which is primary disaster, which was the secondary, which was the tertiary. So there is no set order that it will happen like this. Depends on how it really happens in the real world. Rashmi is asking, sir, which other areas have got affected by GLOF events overseas, that is in other countries? Canada and Alaska, right? And even northern parts of Europe and also in the Siberia region. We have seen such GLOF events happening. Nikat is asking, does India have these sensors to provide early warnings? If you're asking about GLOF, we are putting in place the system. As of now, we don't have it, but we are working on it. The technology is there. Pilot projects are being run. In few years, as I told you, we are planning to have an early warning system for landslides, cloudbursts, and as well as for GLOF events. We don't have it immediately, but the technology is there. The funds, resources are there. We are working on it. So in few years, we might have early warning systems for some of these hazards that we are discussing. Payal is asking, sir, if we evacuate the people or remove the residential facilities, what happens to the area which is significant to religion and tourism? The economy will also get affected. See, you don't have to evacuate all the people, right? Of course, you can't force the people to evacuate. That is only in a worst case scenario when there's no other option. And if the risk is too high, that is when you go for a forced evacuation. Or else you can restrict and regulate the existing activities. You can restrict the number of tourists, correct? You can restrict some of the construction activities. So by placing such restrictions, you can still protect the sensitive slopes and thus prevent some of the disasters. You need not forcefully evacuate the entire town and the entire region. We can minimize the number of people going to the region, minimize the human activities and economic activities through strict regulations. That is a more viable option. Okay. So I've tried taking as many questions as possible. Now let's move on to the next disaster. Let's talk about heat waves and cold waves. Both are very important topics. Heat wave and cold wave. Both are equally important. Let's discuss this for another 15 minutes and then we'll take a short break. We'll come back and we'll complete this topic. So first, let's focus on heat waves. You might have read in newspapers that in the last few days, there are many places in the world which are suffering from intense heat wave conditions. Can you guys name any places? Can you guys name any place which is suffering from a disastrous heat wave right now? As of now, as we speak. Delhi. No. Delhi is getting a lot of rains. Yamuna is flooding. How can Delhi witness heat wave right now? Maharashtra. No. Right now, India is in the grip of the monsoons. So India doesn't have much of a risk of a heat wave as of now. Correct answer is Greece. Very good. Italy. USA. Yes, parts of US. The Death Valley of California. Very good. Very specific. Death Valley in California is one of the hottest places on earth. Right now, California is witnessing record temperatures. But the worst is being seen in southern Europe, in the Mediterranean region, in Spain, in Greece, in Italy. Record temperatures have been reported. And this has led to multiple forest fires. Tourists have been stranded because southern Europe is very popular during the summer season, right? For Americans, for people around the world, even from India, a lot of tourists head to South Europe because you have warmer temperatures during the summer. People enjoy the Mediterranean heat, right? It would be very moderate before, but of late, temperatures are hitting record levels. Previously, Italy, Greece, and Spain, they would never see 41, 42 degrees. Temperatures would ideally be around 35, 36, which was enjoyable for tourists coming from cold countries. But right now, we are witnessing a very rare and extreme phenomena. It is quite unprecedented. So massive wildfires have been triggered. Thousands and thousands of tourists are stuck and stranded and they are being evacuated, right? People are suffering from heat wave related stress and disorders. And it's having a huge impact in Italy, Greece, Spain, and other South European countries. So that is why topic like heat waves becomes very important. India is a very big victim. Before the monsoon season started, India was very badly hit. In fact, every year, India suffers from devastating heat wave conditions, particularly in Delhi, parts of UP, Haryana, Punjab, right? Even Rajasthan, then parts of Madhya Pradesh, Bihar, and also interior parts of Karnataka, Maharashtra, and Telangana as well. There are several places in India which are highly prone to the impact of heat waves during the summer months. So let's understand what exactly is a heat wave. What is its impact? What happens to human beings when we are subjected to such extreme heat? What happens to the environment? What happens to animals? What happens to our economy? This is something we should understand. So a heat wave is a type of an extreme weather event. Just like heavy rainfall, cloudbursts, cyclones, heat wave and cold wave are also extreme weather events. It's a weather-based phenomena. It's a meteorological phenomena. All right? Heat wave is a period of abnormally high temperatures where the actual temperature, actual maximum temperature, crosses the normal maximum temperature of the given place. That is the simple definition of a heat wave. In simple terms, let's say in a place like Delhi. During summers, maybe Delhi's normal temperature, normal maximum temperature is 43, 44 degrees. But if Delhi reports temperatures of 47, 48 for 2 consecutive days, and if it's recorded at multiple stations, then the concerned nodal agency declares that a heat wave has begun. That is, if actual maximum temperature, AMT, the actual temperature being recorded, if this crosses the normal maximum temperature significantly, by a certain margin, by a certain threshold, then the concerned nodal agency declares that a heat wave has begun. Is that clear? Does anyone have an idea which is the nodal agency for giving these alerts for heat wave and cold wave? Which nodal agency in India is responsible for giving heat wave alerts and cold wave alerts? Very good. IMD. Many of you are getting it right. IMD is the nodal agency, the India Meteorological Department. IMD tracks the temperatures as well and monitors heat wave, cold wave conditions and gives out these alerts. So IMD looks out for the actual maximum temperature and sees if it is significantly higher than the normal maximum temperature. All right. This is the simple definition. But there is an exact criteria. There is a specific criteria and a threshold which has been defined. So if this criteria is met, that is when IMD declares the start of a heat wave in a particular region. Before we look at the criteria, let's see which is the season during which we witness heat waves in India and which parts of India are affected. Please write this down. It's important for your prelims as well. Northern India and Northwest India. Northern India and Northwest India. So we can call it Northwestern India. This is the most vulnerable region, stretching from Punjab, Rajasthan to Haryana to Delhi, UP, Madhya Pradesh to even parts of Bihar. This whole stretch, right? Even parts of Gujarat as well. This whole stretch is the most vulnerable for heat wave during the summer season. Of course, heat waves occur only during summer. You can't expect heat wave during rainy season or during winter season. Got it? Next, south central parts of India. This includes parts of Madhya Pradesh, Maharashtra, Karnataka, Telangana, Andhra Pradesh, and parts of Odisha. South central parts of India. These are the two most prone regions for heat wave conditions. All right. The season during which we witness heat wave in India is usually between March to June. That is, winter will usually end by Jan to Feb. Correct? By end of Jan, winter season comes to an end. Then we enter a spring season, which is around Feb to March, and then the summer season begins, the brutal summer season. This comes to an end with the arrival of monsoons in June. Monsoons will arrive in June. By first week of June, monsoons will be here, right? It's the period between this, from February to June. All right? By end of Feb, temperatures start rising. By March, very high temperatures start getting reported, and April, May is the worst summer season across the country. By May, pre-monsoon showers will come in. There will be some western disturbances, and by June, monsoons would have arrived. So the period between this, from March to June, to be very specific, is the heat wave season in India. Is that clear? So please remember this time period, March to June, because spring would have already started by end of Feb. Temperatures start rising from March onwards. By May, pre-monsoon showers, western disturbances set in and they moderate the temperature, and by June, monsoons are here. So from March to end of May, these 3 months, that is the deadliest period. Worst case, it can extend till July as well, but usually it's between March to June. Now we should understand what is the criteria to exactly declare a heat wave. We should understand what is the impact of heat wave. All right. So we will discuss this in detail, because heat waves are responsible not just for physiological stress on the human body, it can even turn fatal. Many people in our country lose lives because of heat wave conditions. Even around the world, a lot of people get killed because of heat waves. All right. A lot of people fall ill and sick. They undergo a lot of physiological stress when they're exposed to the heat, because human body or any life form, any organism, it can't withstand extreme amounts of heat. If you're exposed to these dangerous conditions for many hours, you will suffer from physiological stress. Your body struggles, it goes through a very tough time, causing several problems which could eventually turn fatal, where the person could die as well. Is that clear? That's how heat wave turns into a disaster. Hundreds of people lose their lives every year. All right. So there are several factors responsible here. Of course, there are natural factors, abnormal weather conditions, the lack of wind, the lack of moderating factors, along with human induced factors like climate change and global warming. So it's a combination of these factors that causes heat wave conditions. Now let's understand the parts of India which witness these heat wave conditions by using a map. This is your hazard vulnerability map. And let's also understand the criteria laid down by IMD to declare the start of a heat wave. Now, please observe this map. You can identify how the western parts of India, you can see the western parts of India here, and the northern parts of India. Correct? Then you have the southern and central parts of India, the south central parts of India. These are the places in our country which witness these record temperatures, from Gujarat to Rajasthan, Punjab, Haryana, Delhi, even parts of UP and Bihar, Madhya Pradesh, Jharkhand, Chhattisgarh. Sometimes it extends to Odisha as well. Then Karnataka, Maharashtra, Telangana, and Andhra Pradesh. They have the highest likelihood of suffering from heat wave conditions. So, northern India, western India, parts of southern and central India. All right, between March to June. So, according to IMD, the Indian Meteorological Department, which is under the Ministry of Earth Sciences, there is a specific criteria, a threshold criteria that has been laid down to declare the start of a heat wave. All right. So let's take a look at this after a short break. Let's take a 15 minutes break. It's almost 6:45. Let's come back at 7 p.m. Let's come back at 7 p.m. We'll discuss the criteria and then talk about the impact and what we can do through disaster management. Similarly, we'll discuss cold wave as well. All right. So please don't go anywhere. We have some more important topics lined up. So let's cover them after a short break. I'll see you back at 7 p.m. Hello everyone, welcome back to the session. Now let's continue our discussion on heat waves. We understood what is a heat wave, we understood which parts of India are vulnerable. Now let's talk about the criteria for declaring heat waves. As I told you, IMD is the nodal agency for keeping track of temperature, because temperature is a meteorological phenomenon. So IMD tracks the temperature levels. It has a set criteria based on which heat wave and cold wave conditions are declared. With regard to heat wave, IMD considers the actual maximum temperature of a place. If the AMT of a given place exceeds the threshold, a threshold has been set for different regions. This is the minimum criteria needed for declaring the start of a heat wave. To even consider a heat wave, this is the minimum criteria which is placed. 40 degrees for plains, 37 for coastal areas, 30 for hilly areas. Why do we have different thresholds for plains, coastal areas, and hilly areas? It's because altitude of a place, it plays a role in the temperature that is perceived, the heat that you perceive in a given place. Even humidity levels play a role. Is that clear? The humidity of a given place and the altitude, where exactly it is located above the sea level. These factors play an important role in the actual heat that we perceive. In coastal areas, I'm sure you would have been to coastal places like Mumbai or Chennai. You feel oppressive heat in these coastal cities. Why? Because humidity levels are very high. They are located at sea level. That's why the temperature, even if it's let's say 37, you feel that the heat is more oppressive because of the humid levels. The heat that our body perceives will be few times higher compared to a plain region. So in plains, the minimum threshold which has to be crossed is 40 degrees. In coastal stations, the minimum threshold is 37, and hilly areas, it is 30 degrees. This is the first point. To even consider a heat wave, this is the minimum criteria, this is the threshold which has to be crossed. Then after this, there's another important criteria. The AMT has to be significantly higher than NMT, at least at 2 stations recorded for 2 consecutive days. Got it? At a particular place, once the threshold is crossed, then heat wave possibility is considered by IMD. But to declare heat wave, the AMT should be many times higher than NMT, and this should be recorded at 2 stations for 2 consecutive days. And what is the range of AMT which should be higher than NMT? What is that exact range? If the normal temperature, normal maximum temperature of a given station, let's say it is less than or equal to 40 degrees, and in such a place, if the actual maximum temperature is more than +5 or +6 degrees, that is when heat wave condition is declared. And another possibility is that when the NMT, normal maximum temperature of a place, is more than 40 degrees, and if the departure from the normal, that is if actual maximum temperature is +5 or +4 degrees and above, that is when heat wave condition is declared. Now let me explain this with an example. I'm sure the statement has confused many of you. Let's consider New Delhi. When we take New Delhi as the example, first you tell me whether New Delhi is a plain area or a hilly area or a coastal station. That is the first thing we should consider. So where is New Delhi located? Of course, it's a plain area. Very good. It's not a coastal station, of course. It's not a hilly region. It's a plain region. So what is the minimum criteria to be fulfilled? 40 degrees Celsius and more. So this is the criteria which will apply for New Delhi. The second point. Now let's say today in Delhi, 46, 47 degrees is being recorded. Today and yesterday for 2 consecutive days at 2 stations, 46, 47 has been reported. But the normal temperature in Delhi on this given day should have been, let's say, around 41 degrees. The normal expected temperature was 41, but the actual recorded temperature is more than 4 to 5 degrees. The departure from normal is more than 4 to 5, which means a heat wave has started in Delhi. Is that clear? Let's take another example. Let's take a coastal area. Let's take Mumbai. In Mumbai, what is the threshold? Threshold is 37, right? 37 and above, which is the first criteria given here. At a place where the normal temperature expected is less than or equal to 40. In such a place, if the departure is more than 5 to 6 degrees, then a heat wave has started. Let's say in Mumbai, expected temperature is 38 degrees. It's less than 40, right? But it's above the threshold, above the 37-degree threshold. 38 is the expected normal temperature, but the recorded temperature is, let's say, 43 degrees or 44 degrees. It means actual temperature has departed by 5 to 6 degrees from the expected normal. Normally, it is supposed to be 38, but we are recording 43, 40, 44 degrees, which means Mumbai has started witnessing a heat wave condition. Is that clear? This temperature has to be recorded for 2 consecutive days at 2 stations. Now, irrespective of all this, there is a third criteria. If at any place, at any given place, irrespective of it's a plain or a coastal area, irrespective of its temperature levels, if the actual temperature is 45 degrees or more for 2 consecutive days, it means a heat wave has started. Doesn't matter whether it's a plain or a coastal area or a hilly area. Doesn't matter what the normal temperature is and what should be the departure. If actual temperature, maximum temperature crosses 45 for 2 consecutive days, heat wave alert is issued. Understood? So please remember this. Don't mug it up again. Understand the concept. In prelims, it might be asked. In mains, it will not be asked. UPSC will not expect you to replicate the statements. In prelims, you might get a conceptual question. All right? I'll repeat the points so that you can understand again. To determine heat wave, there are certain basic thresholds and criteria laid out. Since the temperature we perceive changes with altitude and humidity, different threshold is set for plains, coastal areas, and hilly region. 40 degrees is the threshold for plain, 37 for coastal station, 30 for hilly areas. All right, this is the minimum criteria. Anything above this, only then heat wave is considered. Next, to declare the heat wave, AMT should be significantly higher than NMT, recorded at 2 stations for 2 consecutive days. Now, depending on what region we are talking about, whether it's a plain or a hilly area or a coastal station, there are 2 set criteria here. In places where normal temperature is expected as less than or equal to 40, if the departure is more than 5 to 6 degrees, then heat wave has started. In places where normal temperature is 40 and above and departure is more than 4 to 5 degrees, then heat wave has started. Then finally, there's one more criteria. Irrespective of the first 2 points, irrespective of all the other criteria we discussed, if the actual maximum temperature crosses 45 for 2 consecutive days, then heat wave is declared. Is that clear? Now let's understand what happens during a heat wave. What is the impact? As I told you, any organism, especially human beings, Our bodies function normally when our ideal core body temperature is maintained. For our body to function at optimum normal levels, the core body temperature should be ideal. If it is too high, if it is too low, right, then there will be devastating consequences on the human body. The human body will be put into severe physiological stress when you're exposed to such extreme temperatures. It could be extreme heat or extreme cold, both are equally dangerous. In case of heat wave, the most likely impact is that your body will become dehydrated. This depends on your exposure. Let's say you are exposed to the peak heat wave for 5 to 6 hours, for example. During the peak period, let's say from 10 a.m. to 4 p.m., right? That's when we often witness the maximum temperatures being recorded. During this period, if you are having outside exposure, if you're outside in the open, playing a sport or working in the open, exposing yourself to this heat, and if your exposure is for few hours, your body will become severely dehydrated. Because to maintain the core body temperature, the body will start throwing that heat out through sweat. Right? Sweating is body's natural mechanism to moderate and cool down the body temperature when necessary. So as you sweat more, your body is losing essential fluids and electrolytes. Critical minerals and the bodily fluids, water levels will be drained out as you sweat more and more, causing severe dehydration. Dehydration causes heat exhaustion, causing heat cramps, and eventually leading to a heat stroke, which can become fatal as well. Is that clear? If you have ever played any athletic sport, right, if you have exposed yourself to such heat conditions, or let's say you've gone on a trek during the daytime during such peak temperatures, or if you have worked in the open, let's say you're a civil engineer, you're forced to work on the field, right, you're exposed to that extreme temperatures for a few hours, immediately you'll get dehydrated and heat cramps will set in. You will experience swelling, inflammation, you experience nausea, you feel as if you're fainting, and people actually faint as well. You get severe headache, you even start throwing up, you might vomit very severely, and muscle cramps will set in. You can't carry out even basic tasks like sitting up and walking. You feel nauseated, you feel dizzy, people faint as well, lose their consciousness, and in a worst case scenario, muscle cramps can become very severe, eventually causing heat stroke, especially if your core body temperature crosses 40 degrees. Your internal organs will start shutting down. It leads to multi-organ failure, causing seizures, inducing coma, and potentially it could become fatal. Multi-organ failure is the end of it. Is that clear? It can cause cardiac arrest, or other organs might start failing, causing the fatal death of the person. So this is the devastating impact of heat wave. It is purely through exhaustion, dehydration, right, that puts your body through that physiological stress, which eventually causes muscle cramps, fatigue, nausea, vomiting, fainting, and possibly seizures and coma and death as well. But the worst part about heat waves is that it affects the poor and the vulnerable sections of the society. The rich, the middle class, even the upper lower classes, they never experience the impact because we have resources, we have measures that we can take, which the poor people cannot afford. This is the worst part about heat wave and cold wave conditions. There is a very big socio-economic discrimination in the case of these two disasters. The socio-economic divide plays a direct role in the impact. Let me explain how. Now, let's say during such heat wave conditions, all of us, right, we either stay indoors, usually We don't work in the open. We are not forced to work in the open, right? You can stay at your house or you're at your office. Even if you're traveling, you have air conditioned cars, right? You have access to cooling solutions. At home and workplace, you might have a AC or a fan or a cooler. You have enough water to drink. You have access to electrolytes. You can purchase electrolytes and drink. So there are many ways through which people who can afford can easily overcome the impact. We don't even feel the impact of a heat wave. It might sound alien to us. It might sound like something we have never experienced. But if you talk to manual laborers, construction workers, street vendors, right, poor people who are forced to work on the street because of their economic necessity, then you will realize the impact of heat wave. There is a huge socio-economic discrimination in the case of such disasters. Street vendors have no other option. Just because there is a heat wave, they can't shut their shops and go home, right? They can't rest. Their livelihood depends on it. Their next meal comes from there. They are forced to work in the open despite the extreme weather because of their economic necessity. They may not be able to afford a fan or a cooler or an air conditioner. They will not have air conditioned cars, right? They can't install cooling solutions at the place where they are working. Same goes for construction workers, rickshaw pullers, all those who carry out manual work, daily wage laborers. They are at the biggest risk. Even farmers, for example, they have to work in the field, in the open. So economic desperation pushes people to expose themselves to the heat. And worst part is that they may not even have access to water, cooling solutions, and shelter. So that is where heat waves have a deadly impact. Most of the people who suffer these conditions, the heat exhaustion, strokes, and eventual death, majority of them come from the poor sections. In rare cases, athletes suffer from this. There are cases where athletes also have gone through heat strokes. There are athletes who have died as well because of heat strokes. And in some public rallies, etc., in some functions and wedding events, there are cases where the impact has been seen, but it's very rare. But regularly, the ones who suffer will be the poor people, right? The daily wage workers, farmers, rickshaw pullers, construction workers, street vendors, they are the most affected. So that is why the government has to pay maximum attention. What can we do? Early warning system is easily available, readily available. We can easily track temperature. IMD already has the task and it can give out alerts few days before heat wave sets in, right? We can provide very accurate forecasts with regard to temperature. So heat waves can be declared few days before, thus giving enough notice to the authorities to act. That is one step. Next, protect the natural buffers. Protect your environment. If you have more forests, lakes, wetlands, and even parks, they moderate the temperature. They naturally bring down the temperature. Is that clear? That's why cities which are having very good forest cover, cities which have more lakes, more water bodies, they don't suffer the maximum impact because these are natural buffers. They moderate the temperature and help in bringing down the impact. Is that clear? So protecting the natural buffers is extremely important. Protecting your forest cover, tree cover, maintaining parks, public parks, providing for conservation of lakes and wetlands and ponds. This is a very, very important long-term measure. Next, since the alerts are given, the local authorities have to ensure they continuously provide water and electricity without disruption. No load shedding should be done during a heat wave alert, because when electricity is available, people can run their fans, air conditioners, and coolers. Thus, they can cool themselves down through cooling solutions. Water supply is critical to keep people hydrated. All right? Then strengthen your public health infrastructure. The hospitals, especially in the government hospitals, right? There should be awareness. There should be sensitivity regarding recognizing and addressing heat-related ailments. I'll give you an example, a recent example. In Bihar, just a few weeks back, multiple cases came up where people were suffering from heat-related illness and physiological stress. Initially, several government doctors wrongly diagnosed the condition. They dismissed the condition, prescribed some medicines, and sent them back. Actually, they were suffering from heat-related stress. They were severely dehydrated. They had to be put on IV fluids, given electrolytes. But government hospitals failed to recognize and correctly diagnose the condition. Several poor people died in Bihar. And the worst part is that since poor people are bearing the impact, many deaths are not even recorded. They are wrongly attributed to some other cause. People think the person died of some other reason. They dismiss this. They don't recognize it happened because of a heat wave. So the numbers which we are recording is many times lower. If the government is telling us 1,000 Indians have died because of heat wave in a year, actual number will be many times more because deaths are not attributed correctly. Conditions are not diagnosed correctly. Many people don't even report the condition. They're not aware. Even if they're suffering from heat exhaustion, they think it is just normal stress and they ignore it because people don't have the awareness. Even hospitals are wrongly diagnosing the condition. So you have to strengthen your public health institutions, especially during summer season, right? There should be awareness campaign. There should be training so that doctors, hospitals are well trained, well equipped to deal with such patients who are coming in. Put them immediately on hydration, give them IV fluids, electrolytes, and ensure that they come back to normalcy. Here, the deaths are preventable. This is a preventable disaster. All right. So strengthen your public health infrastructure. Spread awareness, provide better training to the healthcare workers and the government authorities. Local bodies play a very important role. Municipal corporations, the water board, electricity boards, the discoms, right? They should all know what to do. When there is a heat wave alert, they have to ensure there is no disruption in water supply and electricity supply. The government should mandate private industries, construction companies, and local bodies to provide basic facilities to the people. For street vendors, for construction workers, there should be cooling places available where they can take shelter during the peak summer period. There should be provision of drinking water. There should be cooling solutions provided. And another solution is work can be suspended during the peak hours. Instead of making construction workers, laborers work during the afternoon, start work early in the morning or continue the work in the evening and night and give them a break in the afternoon, particularly between 11 a.m. to 3 p.m. 3-4 hours, a mandatory break can be prescribed. Is that clear? So the industries, the employers have a responsibility. They have to take care of their workers. Construction companies, local bodies, the government institutions, they have to be mandated to give breaks to people. Give them shelter, give them cooling solution, give them drinking water, arrange for electrolytes which is needed, right? Through such basic measures, you can save lives. The disaster is entirely preventable. You should also strengthen your firefighting capabilities because during such heat waves, there will be forest fires, wildfires, and even urban fires. There are plenty of examples. Recently in Delhi, in Mukherjee Nagar, right, which is the hub of coaching institutions, you know what happened? During the summer heat wave season in Delhi, inside an institute, a small crammed up institute in Mukherjee Nagar, there was an accidental fire. Students jumped out from the building, right? So you have to strengthen your firefighting capabilities. There could be industrial fires because of high temperature. There could be a fire which gets caught in an industry, in a factory, which can spread. Forest and wildfires will increase, as you are seeing in Southern Europe, in Greece, in Italy, and Spain. You should have these capabilities to combat the fire, the wildfire or urban fires which might get triggered. And of course, in the long run, you focus on global warming and climate change. Experts believe there is enough evidence to show that global warming is driving these heat wave and cold wave conditions. Is that clear? I can give you one more example as a case study. Recently in Mumbai, the state government committed a massive blunder. The state government organized a government function in an open playground, in an open field. It was an award function. And without putting any thought into the event, the organizers, right, they arranged the event. Thousands and thousands of people were brought in from villages. According to estimates, around 2 lakh people had been assembled because the government wanted publicity. The political party wanted more publicity. They didn't take into account the heat. There was a heat wave alert, by the way. They didn't provide for any roof or shelter. They made people sit in the open, and the event was held in the afternoon during the peak heat of Mumbai. They didn't provide enough water. There were very few water joints available, water cooling stations available. There wasn't enough medical facilities. When you're organizing such a big event, there should be enough ambulances, doctors, and enough responders to provide treatment if something were to happen. None of these facilities were provided. People sat in the heat for several hours, and all of a sudden, people started collapsing. Healthy people who are absolutely healthy, right? Without their own realization, they just felt exhaustion, nauseated, and headache. They felt it was normal. Since the right measures were not taken, they weren't hydrated, they weren't cooled down. They started collapsing. They started suffering from the severe heat stress, and many people were killed. Even before they were taken to hospitals, many people lost their lives. After reaching the hospital as well, it was already too late. Several people lost their lives, and the worst part is that no one has been held accountable for this tragedy. The concerned officials, the government authorities have not been held accountable and punished, even though several people died due to pure negligence of the government. Is that clear? These are examples that you can quote, right? There was a wedding as well. This happened a few years ago, where the wedding planners and the organizers, the family, they didn't pay any attention to the heat wave. They didn't know, they didn't have awareness. They planned a open air wedding in the afternoon. Many guests collapsed, few people died as well, right? So the right measures, if they are taken, you can easily prevent the deaths from occurring. You can prevent the heat related stress, thus minimize and prevent the impact of the disaster. So heat waves is something we often neglect. Even at the government level, there is a certain negligence, at the local level especially. So this requires better awareness, better training. Is that clear? Now let's look at cold waves. Cold wave is another type of extreme weather event. It's like the opposite of heat wave. So obviously, cold wave is nothing but an abnormal cold temperature, which is many times lower than the actual normal temperature. And this causes severe stress on the body. It causes physiological stress, which affects bodily functions and leads to illness and even death. Cold wave is also fatal. So to declare a cold wave, there is a criteria that has been laid out by the IMD. Just like there is a criteria for heat wave, there's a criteria for cold wave as well. And there are certain parts of India which are most affected by cold wave conditions. So let's study this first and then look at the impact and how we can manage the disaster. The minimum threshold needed to declare a cold wave is that the temperature should be 10 degrees or less for plains and 0 degrees or less for hilly areas. That is the minimum threshold. In a plain area, if normally temperature is 10 degrees or less, that's when a cold wave is considered. Hilly areas, if it's 0 degrees and less, that's when cold wave possibility is considered. Coastal areas are not even taken into account because it's not needed in India. It's impossible for a coastal place in India to have such low temperatures. All right. Next, if the departure from the normal is 4.5 to 6.4 degrees, then a cold wave is declared. And if the departure from normal is more than 6.5 degrees, then a severe cold wave is declared. Now take Delhi for example. Delhi is a plane, as we studied. Let's say Delhi is supposed to have 9 degrees as the normal temperature. But temperature has dropped. Delhi is recording 3 degrees. And if this is recorded for 2 consecutive days at 2 stations, it means Delhi is going through a cold wave. All right. Take one more example. Let's say a hill station in Himachal Pradesh or Uttarakhand. Let's say a place like Mussoorie, Kulu Manali region, right, which are known for sub-zero temperatures. Let's say the temperature expected is -1 degrees in the hill station, but there is a departure of 4.5 to 6.4 degrees or lesser than that. Let's say the place is recording -8 degrees. Then it means that a cold wave has begun. Is that clear? Or irrespective of the threshold, if there is a departure of 6.5 degrees or more, even then a cold wave is declared by the IMD. So this temperature, this departure, if it is recorded at 2 stations for 2 days, that's when a cold wave is declared. Now look at the map. It helps you understand the vulnerability. It helps you understand the hazard map and gives you an idea as to which regions of India are vulnerable for cold waves. Of course, the entire Himalayan belt comprising of Jammu and Kashmir, Ladakh, Himachal Pradesh, Uttarakhand, Sikkim, even parts of Northeast India, they're all prone to cold wave conditions, and as well as Punjab, Haryana, Delhi, UP, Bihar, Rajasthan, Gujarat, even parts of Madhya Pradesh and few other pockets. So all these parts of our country can witness cold wave conditions, right? During winter season, there is a blast of Arctic winds that come in, the polar winds. Even though Himalayas acts as a barrier, right? The cold conditions will cross over and affects northern, western and central parts of India. Is that clear? Of course, there are other complex geographical factors at play, but primarily during winter season, the blast of Arctic polar winds that come in, right? And the wind that picks up through the Himalayas. Let's say it is snowing in the Himalayas, right? The cold conditions get picked up by the winds and gets passed on to the nearby regions. So this whole region suffers from intense cold wave conditions during the winter. So we report such conditions usually between December to Jan. This is considered as the peak winter in India. December to Jan is when we witness maximum cold wave conditions in our country. Now, what is the impact? How does it affect our body? When your body is subjected to such extreme cold weather, again, your internal core body temperature is affected. If your core body temperature is not maintained, right, it causes severe physiological stress on the body, causing hypothermia. Hypothermia is a condition where your core body temperature plummets and drops drastically. Hypothermia can induce cardiovascular stress. It can lead to multi-organ failure. And the body parts which are exposed, like your fingers, your toes, right, even ears, they can suffer from frostbite. Frostbite is a condition where the blood vessels at your tips, fingertips, your toes, right, because of the freezing conditions, it becomes completely blocked. The blood supply gets choked and the part itself becomes brittle. Sometimes it breaks off. All right. So people can lose their limbs, their motor organs essentially, hands or wrist or finger, it could get completely frozen, suffer from frostbite, and people might have to go through a surgery to cut off that entire part, because the infection can start spreading. It can become gangrenous, and the gangrene infection can spread. So there are many people who suffer from frostbite and hypothermia, which eventually can turn fatal as well. So the biggest risk is faced by our soldiers deployed in Himalayan heights, the border guarding forces like ITBP, the Indian Army, right? In Kashmir, in Siachen, Ladakh, across the Himalayan belt, they face the biggest risk. Siachen is a classic example again. Many soldiers have lost their lives because of hypothermia. Many soldiers have lost their toes and fingers because of frostbite. Next, mountaineers who go on treks, who scale these Himalayan summits, they face the risk of frostbite and hypothermia. Then anyone who has exposure, especially daily wage workers, street vendors, construction workers, rickshaw pullers, etc. The list goes on. So again, it's the poor people who pay the biggest price. Poor people who are forced to work in the open despite the extreme cold because of their economic desperation, they bear the biggest impact. So again, with cold wave, there is a socio-economic discrimination. It's the poor people who suffer the most, because the rich, middle class, even lower classes, lower middle classes, they can protect themselves. They can purchase jackets, thermal wear, they can stay indoors, they can afford to stay indoors, right? They can install heaters or put a fire or use protective clothing to shield and protect themselves, because they have the money, the wealth, and the resources to afford them. But those who can't pay for these necessities, those who don't have blankets or a place to sleep, those who work in the open, right? They face the biggest risk, especially during night time, during the early morning hours. The worst temperatures are seen between 4 to 7 a.m. 4 a.m. to 7 a.m. during the early morning hours. This is when the temperature plummets to the minimum, right? So you see cases where beggars and homeless people, people in slums who don't have proper protection, then rickshaw pullers and others who sleep in the open, they bear the biggest impact. Many people, they would have been dead before they wake up because of hypothermia. That's why governments create these shelter facilities where people can sleep inside, and they are even given basic bed and blankets and clothing equipment so that they can protect themselves from the heat, from the cold. Is that clear? Apart from this, cold wave has a huge economic environmental impact as well, just like heat waves. If heat waves can trigger forest fires, industrial fires, and have an economic impact, cold waves also have an economic impact. And also, don't forget, any extreme temperature is harmful to every organism, not just to human beings. Plants, crops, animals, birds, they all suffer from these extreme temperature conditions. So there could be an impact on agriculture. During heat wave, crops could be damaged. Productivity will be affected. Farmers in turn will be affected. So don't forget that economic angle. Even extreme cold is not suitable for crops, for plants, vegetation, and for biodiversity in general. So there will be losses to environment and biodiversity and to the economy as well. And during cold wave, the worst part is that it affects several economic activities. Infrastructure, transportation could be thrown completely out of gear. All right? Road and rail transportation, even air traffic can be disrupted due to the intense fog conditions and extreme low temperatures. Railway lines can become brittle and crack. Due to extreme fog conditions, road traffic can become dangerous, and airport operations can also become dangerous and they'll be suspended. If you see in northern India during winter months, railway traffic is shut, airport operations are shut for few hours and few days because of intense cold wave and fog conditions. Then infrastructure can be affected, power grids, especially any electronic equipment. Functioning of this can be affected because of extreme temperatures, both heat and cold wave conditions. Because these devices, they operate under ideal temperatures. So if the infrastructure is not well designed, if the equipment can't withstand these kind of extreme temperatures, there could be a failure of your essential infrastructure, including power grids and other facilities. Your energy consumption will shoot up during both cold and heat wave conditions. During heat wave, people will run fans, ACs and coolers. So electricity consumption goes up. So government has to either burn more coal and cause more pollution, or we have to procure gas and other energy sources, fossil fuel based energy sources, which increases our import bill. During cold wave, people will need heaters. They will use wood fire, again causing pollution, contributing to climate change, and increasing our import of natural gas, which is needed to provide for heating and cooling solutions. Right? So energy bill will shoot up. Providing energy supply becomes a challenge during these peak periods. Now take, for example, how Europe took the hit during Russia-Ukraine war. European countries depended heavily on Russian gas for heating solutions during the winter, and Russia tried to use that as a leverage. Because without Russian gas, countries like Germany and others, they will have no gas to heat, to provide heat within houses and buildings and workplaces. And under those extreme cold wave conditions, people will suffer. So only places which suffer from these conditions know the true impact. Day to day, life gets affected. The cost of living increases. Energy becomes very difficult to provide. Transportation, infrastructure could be disrupted. Agriculture could be affected. So there is a widespread economic impact as well. So please be mindful of this. Please pay attention to understand the broad-based nature of these disasters, heat and cold wave conditions. As I told you, the worst part is that it mainly affects the poor people who are forced to work in the open because of their economic necessity. That is why the government has to pay attention, spread awareness, give out early warning and alerts, strengthen the public health infrastructure, spread awareness amongst the authorities. They should know what to do. They should create shelters, provide cooling and heating solutions, and protect the people during these times. Or maybe give a financial incentive to workers so they don't have to work by force, or ensure that they get a break during the peak conditions. So such solutions has to be designed through a well-planned disaster management strategy. All right. So that completes my discussion on heat wave and cold waves. I hope you guys have understood everything. Now let me know if you have any questions, any doubts. I'll try to answer them. And then we'll move towards few geophysical hazards like earthquakes, tsunamis, etc. Let me know if you have any questions. SMEs, can you please push the questions into the dismiss section? Rashmi is asking how transportation is impacted during cold wave. As I told you, during extreme cold wave conditions, there could be severe fog or smog conditions where fog mixes with smoke, right? That affects visibility. If visibility is very poor in the morning during peak winters and cold wave conditions, road and rail traffic will be suspended. Airport operations will be suspended. That's how transport gets affected. Femina is asking, during cold wave, livestock also gets affected? Yes, cattle, livestock, they will also get affected. Even they can't bear extreme cold wave conditions. Can westerly winds contribute to cold wave? Westerly winds are usually known to moderate cold wave conditions because wind movement is good. It helps in moderating the temperature. But sometimes the westerly wind can pick up the cold air mass from the Himalayan ranges, from the snow-capped ranges, and then that brings colder currents, which increases the cold wave condition. Vaishna is asking mitigation strategies for cold wave. I just explained that. First is early warning, right? Forecast the temperature, give out alerts. Next, awareness, training, spread awareness amongst authorities, amongst the people, right? Educate them, tell them what measures to take, train them as well. Strengthen your healthcare infrastructure. Then ensure that the poor people are given the right protection. Create shelters for them, right? Provide protective clothing, blankets, provide heating solutions. Like, for example, Delhi government has created these shelters, night shelters, where people who don't have a home, they can go and sleep inside. They're even given blankets and protective clothing so they can protect themselves from the extreme cold, right? So those are the basic measures to be taken. Mithun is asking why cold wave is more impactful in the interior of India. Not exactly. Cold wave is impactful anywhere it occurs, be it in Jammu and Kashmir, be it in Delhi or Madhya Pradesh or Rajasthan. Everywhere cold wave has a deadly impact. Vipul is asking why uniform code is required in all construction activity if there is distinguished location. Vipul, your question is not clear. The grammar is not right. You've not structured the sentence. I'm not able to understand what you're asking. So please frame your questions properly. It should be grammatically correct so that I can make sense out of it. Santosh is asking, is there any graph that shows the trend of deaths due to heat wave and cold wave? No, there's no such data which has been collected as such. But maybe there are few organizations which could have done it. So if you try and Google, you should be able to find some data at least regarding the deaths occurring due to heat wave and cold wave. Anushka says, sir, those who live in hilly area, their body would be able to bear it because they live in colder areas, they get less affected by cold waves. That's because people would have adapted. They know what measures to take to protect themselves from the cold wave conditions. Right? Similarly, in hot areas as well, people know how to protect themselves. This is part of traditional knowledge, right? The food they eat, the way the houses are built, the clothes they wear, that plays a very important role. So people would have adapted, and even the body would have slightly adapted. Definitely, people, locals will have a slightly better ability to bear, but beyond a certain point, no human body can bear the extreme temperatures. Sakib is asking, is it real that Western people drink alcohol to keep body warm? It's not just Western people who drink alcohol, right? But yes, alcohol consumption helps in keeping your core body temperature higher. That's true. Abhishek is asking why Delhi, UP, etc. affected by heat wave and as well as cold wave. That's because of their location, the geography, right? You will study more about this geography. In your geography classes, you will understand this in more detail. Because of where Delhi, UP, Rajasthan are located, they suffer both heat wave and cold wave. Heat wave is mainly because of the extreme temperatures during summer, right? And the lack of moderation. And cold wave is mainly because of the polar blast coming from the Arctic and the cold currents getting picked up from the Himalayas that brings the cold wave. So the places are located in such a region that they suffer from both heat wave and cold wave. Guru Charan is asking which is more severe, cold wave or heat wave? Both can be severe. How can you compare them? It's apples and oranges, right? Both are equally dangerous. Cold wave and heat wave can both cause a severe disaster. Santosh is asking, does heat wave, cold wave depend on altitude? Yes, that's what I mentioned when talking about the criteria, right? Altitude makes a difference in the temperature that we feel and perceive. That's why there is a different threshold for plains than hilly areas, etc. Devansh, example of infrastructure getting affected during extreme temperatures. I just gave you the examples, right? Your power grids could get disrupted. Transportation could get disrupted because of extreme temperatures. Railway lines, the tracks could become brittle. They could expand, contract due to extreme temperatures, abnormal temperatures. So infrastructure, transportation can get affected because of these extreme temperature conditions. Vipul is asking why uniform code is required for construction activities in GLOF measures, as every geographical location has their own demand and necessities. See, when it comes to construction code and building standards, of course, it changes from place to place. Local bodies are responsible for enforcing the building standards, right? There are building bylaws brought out by the local bodies. Place like Delhi, which is in a seismically active zone, building standards needed are different. Or in a place like, let's say, Bangalore or Chennai, depending on the hazards, the building standards have to be different. So we are not saying that building standards have to be uniform everywhere. Depending on the place, depending on the threats present, the hazards present there, building standards should be accordingly designed and enforced. Femina is asking, westerly winds, do they contribute to heat wave and cold wave? Yes, westerly winds coming from the Mediterranean, they are known to influence weather patterns in northern and western parts of India. So they do have a role to play in heat wave and cold wave conditions. Has government taken any measure for soldiers to tackle cold wave conditions? Obviously, the Indian Army and the Home Ministry, which is responsible for ITBP, right? They have provided them required clothing, specialized Arctic clothing equipment has been given to them. They also provide special medical care, training, and they acclimatize to the temperature and the higher altitudes, right? The soldiers, before they are deployed in these adverse places, they go through extensive training and acclimatization. The body gets accustomed to it. Plus, they are given enough clothing, gear, equipment, and other facilities to protect the soldiers from these adverse conditions. Okay, let's see one last question. Um, Anu is asking, are there any man-made factors for heat wave and cold wave? Man-made factor would be global warming. The climate change and global warming we have caused, right? That of course influences these extreme weather events. Heat wave, cold wave conditions are driven by global warming as well. So we can say that is a man-made factor contributing to heat wave and cold wave. Okay, we've taken enough questions. Now let's come back to our discussion. We still have around 30-35 minutes left. Let's take a look at the next disaster, which is a geophysical hazard caused because of Earth's geology, caused because of Earth's tectonic movements. Let's talk about earthquakes. As we discussed in the first class, it is a geophysical hazard. It is a type of geophysical hazard that occurs due to the Earth's geology and the physical movement of the tectonic plates. Right? Tectonic movement induces seismic activity below the Earth's surface, and that is responsible for a type of disaster called as an earthquake. So, earthquake essentially is the shaking or the trembling of the Earth's surface caused by the seismic waves that are released during this tectonic activity. Is that clear? Below the surface, in the Earth's crust and in the upper mantle, we have these tectonic plates on which the continental landmass is sitting. The tectonic plates are not constant, they are in movement. You would have studied the continental drift theory, you would have studied tectonic plate movements in geography, right? So, as they are sitting on liquid fluids in the mantle region, these tectonic plates, they keep moving, right? Centuries ago, millions of years ago, we had one super landmass called the Gondwana land, where almost all the continents we have today were united into one single landmass. But over millions of years, they have drifted apart because of tectonic plate movement and continental drift. And so as they move apart, these plates below, they interact with each other. So when these tectonic plates, when they rub against each other, or when they collide into each other, right? Or there is a possibility where a plate can subside against another plate, where a plate dives under one plate, or a plate can move against another plate like this perpendicularly. So such activity which happens at the fault lines, which is present at the intersection of tectonic plates, this tectonic movement at the fault line can generate massive amounts of energy when there is a slip that occurs at the fault line. Now take for example the Indian plate, which crashed into the Eurasian plate and it is subsiding under the Eurasian plate. I hope you guys know that the Indian plate is diving constantly under the Eurasian plate. This is what creates the Himalayan mountains. The Himalayas were created because of this tectonic activity. As the Indian plate subsided and dived under the Eurasian plate, it pushed up the mass, the land mass, the lava, the magma, everything got pushed up, and the Himalayas continue to grow. Right? Even now, constantly the Himalayan mountains keep rising because of the active tectonic movement happening under the Himalayan belt. Now, these plates which are held together, this is a fault line. So there is a tremendous amount of potential energy that gets built up. Now, what will happen if there is a rupture that could happen? Right? If the fault line, at the fault line, if the plates were to move or break apart, or if they were to slide against each other, the massive amount of potential energy gets released, turns into kinetic energy, and travels as seismic waves through the Earth's crust. These waves induce a trembling. It essentially shakes the Earth's surface, and that could turn into a major disaster. The threat is mainly for buildings, cities, and infrastructure. That's why I took an example in the first class. I told you, now imagine a desert. It's an uninhabited desert. There's no human population, not a single human being, no building, no infrastructure is present, no cities are present, no villages as well. Imagine it's a barren land. In such a land, if a massive earthquake were to happen, it will never be a disaster. It's only a hazard because there's no loss of life. Earthquake will not have any impact in such an uninhabited place, in such a barren land. Correct? There might be some environmental impact, but other than that, there's no other impact. So it's not exactly a disaster. It's only a hazard. But if the same earthquake were to hit a populated city or where major infrastructure projects are present, right? The buildings the infrastructure which is resting on the Earth's surface, their foundation will be shaken. And if the foundation is not strong enough and the design of the building is not resilient enough, the shaking which is induced can bring down the buildings and the structures and all the infrastructure. This is where earthquake becomes a major disaster, an instantaneous, spontaneous disaster that can kill lakhs and lakhs of people, millions of people. Earthquakes have the potential to flatten and wipe out entire cities and entire regions within seconds. So that is why earthquakes become extremely dangerous. It's a result of plate tectonics happening below the Earth's surface in the Earth's crust and the upper mantle region. The destabilization at these fault lines where the tectonic plates are intersecting, this induces the shaking or the trembling that we experience. When there is a rupture at the fault line, when the tectonic plate breaks or moves apart or slides against each other, right, the massive energy that is released travels as seismic waves that strikes the Earth's surface. So this shaking can be dangerous for buildings, cities, and infrastructure, which can cause massive loss of life. All right. Other than the tectonic activity and rupture at fault lines, even volcanoes can induce an earthquake. A massive, powerful volcano, when it erupts, the speed and the pressure with which the magma lava will explode out, it can induce shaking of the Earth's surface, causing an earthquake in the region. This is also a possibility. Volcano causing an earthquake. Is that clear? A massive volcano, which is a primary disaster, can induce an earthquake in the nearby region. That's also a reason for earthquakes, apart from tectonic activity. So please don't assume that just tectonic movement and fractures at fault lines is the only reason responsible for earthquakes. In fact, these phenomena are interrelated. Earthquakes and volcanoes are interlinked, right? So this destabilization occurring at fault lines can cause a massive volcano that in turn induces the shaking, causing an earthquake in the region. So please understand this link between an earthquake and a volcano. Both are very closely linked to each other. Apart from these natural factors, there could be human-induced earthquakes as well. Man-made earthquakes are possible. Man-made earthquakes are also possible. Can anyone think of an example? Any example of man-made induced earthquakes? Sridevi and Neil are saying mining activity. Okay. Blasting. Nuclear tests. Dams. Very good. A nuclear test that's conducted underground, especially, can induce a man-made earthquake, at least in the nearby region. In fact, the shock waves can travel throughout the Earth. Nuclear explosion that's conducted under the ground, like our Pokhran tests, they release a massive amount of energy that induces shaking in the Earth's surface in the crust, and the waves can travel. All right. In fact, that is how international organizations and other countries can detect if another country has conducted a nuclear test. There is a global infrastructure for that, to detecting underground nuclear tests. You guys might have heard about a convention called CTBT, the Comprehensive Test Ban Treaty. It bans nuclear testing. Under CTBT, there is an organization called CTBTO, Comprehensive Test Ban Treaty Organization. The task of this organization is to detect any nuclear test conducted by any country in the world. So CTBTO, along with IAEA, International Atomic Energy Agency, and few other partner countries, they have created an infrastructure around the world to detect any kind of nuclear test. Be it a nuclear test conducted in the seas or the oceans, underwater nuclear test, or atmospheric nuclear test, or underground nuclear test. So various sensors have been deployed, various technologies have been deployed to detect such nuclear tests. When it comes to detecting underground nuclear tests, there are seismic sensors installed around the world that can pick up these waves induced by a nuclear test, thus confirming that a country has conducted a nuclear test. So this is a human-induced earthquake, at least in the nearby region. The impact will be less. You can't compare this with a natural earthquake, but still, the shaking of the Earth's surface can be induced by a nuclear explosion conducted underground. Another possibility is mining, construction, and related explosion activity. At least in the local area where mining is being carried out, where tunnels are being dug, where construction is happening in a hilly, slopey area, where explosions are being carried out for projects and infrastructure projects. In such places, it's possible to witness minor earthquakes in the nearby region. Is that clear? Because when tunnels are dug in sensitive, delicate areas, can cause a trembling, causing a minor earthquake in that region. Next, there's one more explanation, there's one more reason because of which man-made earthquakes are possible. It's believed that dams, that is reservoirs, can induce local earthquakes. But however, this is a controversial theory. All right, please remember it's not completely proven. The opinion of geologists is divided whether dams and reservoirs can induce earthquakes or not. Some argue that it is possible. They say there is evidence as well to show that dams and reservoirs, as they carry massive volumes of water, this can destabilize the Earth's surface in that local area, inducing local earthquakes. But there are critics as well. There are other geologists who have come up with their own theories and research, pointing out that dams and reservoirs are not responsible. There is some other reason causing these local earthquakes. So it's a controversial theory. It's disputed. It's not completely proven. It's debatable, but you should know that it's possible. All right. In India, there is one such place. In our own country, there is one place in particular where it's believed that earthquakes are happening locally because of a particular dam. Do you guys know where it is located? Can someone tell me in the comments? In Maharashtra. Very good. Labdi has said it's in Maharashtra, but do you know where in Maharashtra? Mithun and Padmavati and few others have given the right answer. The Koyna Dam in Maharashtra. Let me write it here. The Koyna Dam in Maharashtra. Around the Koyna Dam, there are frequent tremors, localized tremors that are felt by the local people. Several studies have been conducted by